right, guys, so this is where we finished off yesterday. Yes. Mm-hmm. 8.1. Yep. Yeah. So this is where we finished off yesterday because we did find that x was 8. And this one here we can just look to see that 6 goes to 12, 8 to 16, 5 to 10 is all a multiplication of 2. So our scale factor for this is 2. And understanding that, well, we could see that the missing side is going to go from 4 to 8 because we're just going to multiply 4 by 2 and we get to 8. Now, we have a few of these left. I think this is actually the last one of this type before we move on to the next part. And if we wanted to look at this here and we want to find Km, this here, we could say x over what? Is going to equal because x over 35, those are the same lengths, or corresponding lengths. They're not the same, because if they were, that would just give us 1. But they're the corresponding lengths. And 48 is another part of our first triangle, and 40 is its corresponding length. Now, what did we do next? We would multiply both sides by 35. Because here the 35 and 35 would simplify, telling us x is equal to 48 over 40 times 35. Now at this point here, we can really just type this into the calculator to get the answer. And if we type it in, we get what? 42. Because if we wanted to simplify this by hand, we could, because 35 and 40 are both divisible by 5, which would reduce this to 7 and reduce this to 8. 48 is actually divisible by 8, because 6. So that would reduce that to 1 and give us 6. So it leaves us with 6 times 7, which is 42. Because if we didn't have a calculator, we could simplify just reducing fractions to try to get down to the answer. Okay. Perimeters of similar polygons. Well, if two polygons or two figures are similar, well, then their perimeters are going to be similar to each other. They're going to be the same scale. So if we looked at this here, I'm just going to throw numbers down, 2, 4, 6, 8. And let's say 8, 16, 24, 32. Really, we just have a scale of 4. And if we looked at the scale factor for this here, because we could say any of these here, so if we're going from here to here, we can say 2 over 8, which is, well, 1/4, which is the same as 4 over 16, which is the same as 6 over 24, which is the same as 8 over 32. These all reduce to our scale factor of 1/4 because we're going from smaller to bigger. Actually, it was going this way. I had them flipped. For 1/4, if we went the other way, it would be a scale factor of 4, yes? Now, what they're talking with perimeter is comparing those. Well, perimeter is just adding all the sides together. So if we're going the same direction, bigger to smaller, we can say 2 plus 4 plus 6 plus 8. That would be the perimeter of our figure here. The other figure would be 8 plus 16 plus 24 plus 32. Well, 2 and 8 is 10, 4 and 6 is 10, and 10 and 10 give us 20. 8 and 32 is 40. 16 and 24 is 40, and 40 and 40 is 'So the scale factor for our sides and the scale factor for our perimeters are actually the same, which is kind of nice, because if we're given this problem here, so we're told that they want to build a new swimming pool, an Olympic swimming pool, is a rectangle with a length of 50 meters and a width of 25 meters. The new pool will be similar in shape to the Olympic pool, but will have a length of 40. Find the perimeter. Well, we're given this one here, yes? Well, perimeter is just adding all of these lengths to this one here is 25. This is 25 plus 25 is 50 plus 50 is. So the perimeter for this is 150 meters. So we want to find the new pool perimeter. That's what we're wanting to find. Well, if we're setting up our proportion, just kind of like what we did the last time, the perimeter is what we want to find, yes? And we would put it over what? The current perimeter, which is? Now they told us the new length is, and we would put over what? 50, because they told us the length of the original pool is 50. Guys. So the proportion for the perimeters is going to be the same as the proportions of our lengths. Well, what do we need to do? Multiply both sides by 150. Well, luckily this one here, this multiplication is not too bad, because we're saying 150 divided by 50, yes? What's 150 divided by 50? 3. So we're really saying 3 times 40. So the new perimeter is 120 meters. Because when we talk about perimeter, we're always talking about just meters or our units to the first power, yes? Singular length. And if we talked about area, area is in what? What kind of units? Square units, yes, because area is squared. So what do you think we would do with our scale if we talked about area? We would square it. So area works the same way as what we did here, but our factor, so that would be our 40 over 50, would have to be what? Squared to match up with our square area. What do you think we would do with volume? Cube it. Because the volume would be our cube scale factor. So we can do this with volume, area, or perimeter. We'll do one more with perimeter, and then the last thing we actually talk about is area. We won't talk about volume. Your neighbor has decided to enlarge his garden. The garden is a rectangle with a width of 6 feet and a length of 15 feet. Garden, 6, 15. The new garden will be similar to the original, but have a length of 35 feet. Find the perimeter of the original and the enlarged garden. So original So to find the perimeter of the original, we're just adding all the side lengths together. And this would be 6 and 15. Well, 15 and 15 is 30. 6 and 6 is, which would give us a perimeter of 42 feet. Well, they didn't give us enough information for the enlarged garden to be able to just add the side lengths together, because all we know at most is that half of it is 70. Because 35 and 35 would give us 70. We don't know what the other two sides are. So we want to find that perimeter. But we're told, and we found that the original perimeter is 42. What would we do for the other fraction? 35 over 15. Since we did the enlarged over the original for the first fraction, the other fraction we need to enlarge over the original. Now our next step would be to multiply both sides by 42 to get x by itself, as these would simplify, leaving us with x is equal to so our enlarged is 98. That's it. That's all we have to do for this here. Questions on any of this? I feel like y'all are comfortable with this here, yes? Now, to set up the other fraction, what side length would I connect with 10? FG are 15. I mean, KJ would also work. They're both 15. We need to match up those sides. We couldn't use 9 or 12 because it is not a corresponding side to the given side length that they gave us. Perimeter. Okay. Now, careful on these here because they gave us the ratio, yes? I want to look at both of these here before we move on because this here might trip someone up. Two polygons are similar, the perimeter of one polygon and the ratio of the corresponding side lengths are given. Find the perimeter of the other. So here, we're wanting to find the perimeter of one over what? 66, yes? Are we finding the smaller perimeter or the bigger? What did they give us? Perimeter of the smaller, yes? So we're going from smaller to bigger, yes? And whenever we go from smaller to bigger, the scale factor is what? Greater than 1 or less than 1? Greater than 1, yes? So they gave us the scale factor of 3/4, yes? Exactly. Because that scale factor is not going from smaller to bigger, it's going from bigger to smaller. So this one here, we have to flip it to get what we want. Because if we wanted to use it as 3/4, we would have had to have 66 over x is equal to 3/4. Well, if I flip both of them, we will get the exact same thing. Here, we just need to multiply both sides by. These will cancel. telling us x is equal to 88. So these here, because there are ones like this on the homework, we do have to pay attention of which direction we're going. Because if it had told us that we were trying to find the smaller one, then we could have left it as 3/4. But since we're wanting to go to the bigger one, we need it to be 4/3. So we can go on and look at this one here. So we're trying to find the perimeter of one. They gave us the perimeter of the other. And our scale ratio is 2/5. Are we going to leave it as 2/5 or flip it to 5/2? Because where are we going? Are we going from smaller to bigger or bigger to smaller? Bigger to smaller, because they gave us the larger one, yes? So we're wanting to find the perimeter of the smaller. So whatever this value is, it should get smaller. So we would have it as 2/5. Here we'd multiply both sides by 5, which will tell us that x is equal to, because 5, 1, 35 is 7, 34 meters. And that's it. Questions on this here? Are you ready to look at the last part? Yes? And that's dealing with area. And our proportions of areas is going to be the same as the proportions of the side lengths squared, our scale factor squared. So if we know what the area is of one and two of the side lengths, all we've got to do is square those side lengths to get the proportion to area. And I mean, that makes sense in theory and in kind of I can show it with rectangles. So to make this kind of easier to work with, we can say that this is 2L and 2W. Well, area for a rectangle is length times width, yes? Now the area for our new one over here, area is equal to 2L times 2W, yes? 2 times 2 is? This is our new area. So we're saying that comparing the areas, so we have the length to, where am I going? Try this again. Because our new one is 4 LW. We increased everything by 2, yes? And got that the area is 4 LW. The original area is just LW, yes? So if I reduce this, well, it just reduces to 4 over 1 or just 4, yes? Let's compare the sides. I'll pick just lengths. Because our new length is 2L, our original length was L, yes? What is 2L divided by L? 2 over 1, yes? Well, that's not the same as our 4 over 1, is it? This is why we need the square, because really we're multiplying it as that square property, which would give us 2 over 1 squared, which really shows us that it is 4. So when we talk about area, we're talking about this square unit in similarity. So if we look at this here, the area of this triangle is 36. We want to find the area of the other triangle, yes? Not quite, but they are proportional. So we can say x over 36 is equal to blank over blank, because we were given one of the lengths. Because the length of the new one is, and the length of the old one is 10. But because what are our units in area? There are in centimeters squared, yes? The lengths for 5 and 10 are both in just centimeters. This is also why we need to square it, because we need them in the same units. Whenever we talk about proportionality, the units need to be the same. Oh, thank you.
Triple A's?
Yes.
$40 worth of batteries right there.
Yeah, we go through a lot of them. So this here, we can square this at this point if we want to. Or what did we do in the other ones? We multiplied both sides by the bottom of the fraction, which in this case would be. And these would cancel, telling us that x is equal to 5 over 10 squared times 36. And we could type it in the calculator at this point here, just as we have it. Now, if we wanted to, and we squared it first, because 5 over 10 squared would be 1/4. And 1/4 times 36 is 9. And if you did 5 over 10 squared times 36, you should also get 9. I think some of y'all typed it in as a whole. Typed it in like this and got 9. Yeah. Either way works. Any questions on this here? This is the last one we'll look at, and I think there's only 2 left on the notes. Yes. Now, they told us that the area of RST is 75 square meters. We want to find the area of PQT. Area PQT over is equal to 14 over 10, and this would be, because again, we put 14 on top because we're trying to find the area that has a side length of 14. Since we put its area on top, its side length has to go on top as well. What do we do next? All right, we can multiply both sides by 75, as these here would cancel, telling us that x is equal to 14 over 10 squared times 75. Meters squared. And that'd be it. Any questions on this here? Wrong way. And that's all we're doing on this here. Drifting. Yes.